Greetings everyone, today we're going to explore solving quadratics using the quadratic formula. So far we have explored solving quadratics with factoring, solving by square roots, and by completing the square. And the completing the square, even though it's a nice step-by-step process, because it is so repetitive, a formula was the quadratic formula, which you do have a foldable for this. If you don't, make sure you jot this down in your notes. It is something you will want to memorize if you don't already have it memorized. But we use this formula to solve quadratics that are written in standard form. So you need to identify your A value, B value, and C value. Make sure you pay attention to their signs, positives, negatives. And again, this really is just the completing the square steps put into a formula. Another way to kind of show you how this connects, if I separate that denominator, then we have a nice clean real part and an imaginary part, which looks more like our answers with completing the square. Let's talk about a specific piece of the quadratic formula, and that piece is called the discriminant, and it's the piece that's under the radical sign, so that would be called the radicand. What the discriminant does is it tells you how many solutions you're going to have for your quadratic. So if I arrive at a negative, well, think about that. If I have a negative under a radical, that becomes imaginary. So if the radicand, the discriminant, is negative, you're not going to have any real solutions. You'll have a solution, just not real. If you have a radicand that is 0, well, the square root of 0 is 0. If I add or subtract 0, it's not going to change. You're going to be left with negative b over 2a, which means you're going to have one answer because you're not going to have the plus or minus anymore. So 0 means I'm going to have one real solution. If you have a value greater than 0, so if I arrive at a radicand of 15, well, there's going to be a plus and minus in front of that still, which means I'm going to have two real solutions. In your foldable, we do have these examples. If you don't have it, just jot them down. The first thing you, of course, always want to continue to do, make sure it's written in standard form and equal to 0. We're going to identify our A value, our B value, and our C value based on that standard form. All right, let's plug it into the formula. So actually, first let's talk about the discriminant. Let's talk about how many solutions we're going to have. If I use the discriminant, I'm going to have a 4 squared minus 4 times A times C. 16, subtract 4 times 2 times 1 gets me 8, which gets me to 8. That's a positive integer, so that means we are going to have two solutions. All right, now let's use the formula. Now, we already did all this work to get to 8, right? So as I start plugging in the formula, opposite b, right? This is part of the formula. So negative 4 plus or minus the square root all over 2 times a. Now, instead of redoing the discriminant work, let's just take this 8 we already used and write it under the radical symbol. All right, let's simplify. Square root of 8 breaks down to a 4 and a 2. So I'm down to negative 4 plus and minus 2 radical 2 over 4. Now I can simplify this further. If I look, every piece is divisible by 2. So my final answer is going to be negative 2 plus or minus square root of 2 all over 2. All right, let's take a look at example 2. So the first thing I notice is I need to write my equation in standard form. So I'm going to kick everything to the left side. So I'm going to have x squared plus 2x plus 7 equals 0. If you can keep that leading coefficient positive, it sometimes makes things a little easier. So let's identify my parts. That means my A value is 1, my B value is 2, and my C value is 7. Let's start off by working on the discriminant, meaning the radicand. So b squared would be 2 squared minus 4 times a times c. If I simplify that, I've got 4 minus 28, which gets me to negative 24. So that means there are no real solutions because I have a negative, and that's going to create imaginary, right? All right, let's work on the formula. So opposite b would be negative 2 plus or minus all over 2 times a. Well, that's 1, right? Now, because I did the work for the discriminant, let's just bring that over, negative 24. I got a little bit of simplifying work to do there, don't I? The I is going to come out to make that radicand positive. 24 breaks down to 4 and 6, which becomes 2 radical 6, and that I would get tucked in between, right? So let me simplify this. That means I have negative 2 plus or minus 2i radical 6 all over 2. Every term has a value that can simplify. So our final answers are going to be negative 1 plus or minus 1i radical 6. Technically, you don't need this one, right? You can leave that off, but we do need the first one for sure. All right, now without this template, let's just work on the formula. If it's helpful to do the discriminant off to the side, consider doing that if it helps you stay organized. But I'm just going to straight plug right into the formula. But first, I need to rearrange. I'm going to kick that 9 to the left side by addition. I'm going to label my A value, my B value, my C value, just so I stay organized. Let's use our formula. Opposite b, so instead of negative 6, positive 6. The square root of b squared, you're squaring the negative as well, okay? Be careful if you're using your calculator. Subtract 4 times a times c all over 2 times a. So I'm going to work on that discriminant first, right? So as much mental math as needed, you decide. I'm going to do the squaring first, so it's 36 minus, and I have 9 times 4, which is 36. So that makes sense. This is going to become 0. So 6 plus or minus 0 over 2. Well, plus or minus 0 means I'm only going to have one answer. So x is equal to 6 over 2, which is just 3. So this makes sense because our discriminant was 0. Graphically, we'll learn about that more in the next unit. What does it mean when there's only one number? All right, let's try another one. First thing I'm going to do is I'm going to rearrange. I like the x squared being positive, so I'm going to move everything else to the other side. Alrighty, let's use our formula. Opposite, I'm going to label, sorry. Let's label. So I've got a 1, a 6, and a 5. Opposite b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Again, if you know it's just going to remain 2 on the denominator because your a is 1, you don't have to show every little step. Let's take care of that discriminant. I'm going to have 36 subtract 20 on this one, which is going to get me to negative 6 plus or minus 16 all over 2. Let's keep going. The square root of 16 is 4. Now, we've had a little bit of trouble with this in the past, so make sure you are reading this. This is 2 separate problems, okay? We got to think of it as negative 6 plus 4 over 2. And we have to think of it as negative 6 minus 4 over 2. See how I wrote that separate? Maybe you write it separate if it helps you think through. So negative 6 plus 4 is negative 2. Negative 2 divided by 2, negative 1. Negative 6 minus 4 is negative 10 divided by 2 is negative 5. So my solutions are negative 1 and negative 5. Not a point, just 2 separate values. Now, what this actually means, you guys, if you get two nice, perfect answers, that actually means I could have factored, right? That would give me a 5 and a 1. And if I solve them, negative, negative. So it just goes to show that quadratic formula always works. Even if it was factorable, even if it was a solve by square roots, always use quadratic formula. All right, let's try another one. I'm going to rearrange first. I'm going to move everything to the right side this time in an effort to keep that leading coefficient positive. My a value is larger this time, so keep an eye out for that. And let's plug in. Opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, let's simplify that discriminant. I'm going to have 81 subtract 12 all over 6. Let's keep going. That's negative 9 plus or minus the square root. See, 71. We've got down to 60. 9 over 6. Now, let's talk about that radicand. Is there a perfect square that would simplify? In this case, there's not, right? So a common mistake here, so this is my answer actually, x equals negative 9 plus or minus the square root all over 6. I have two real answers. So the common mistake is sometimes students are like, oh, 9 and 6 simplify, but there is not an integer, a coefficient in the third term that I can divide out, so I can't. Another way to look at it, if this is helpful, is really we have negative 9 over 6 plus or minus square root of 69 over 6, right? So you could, if you want to write it that way, simplify that piece, but you can't simplify this piece, right? So if you can't divide all three pieces, then just leave it as is. All right, we tried to do an example of every type we're going to encounter. No real solutions, one solution, two solutions, reducing radicals, perfect squares, right? So make sure if you have questions, you ask, check out the Sabre Center schedule if you need some targeted help. And then as always, check out Google Classroom for what your task is today. And until next time, have a good one.